Alright, time for another draftphysics.com, debatephysics.com, also video presentation. This is sort of the real draft physics part, so I'm just going to do a draft video trying to explain how I see the universe, okay, and in this particular idea of a bent geodesic or time dilation or space-time thing, okay, versus some more Newtonian understanding of the fact that there's just three dimensions of space and there's stuff in it and it's going on trajectories where it ends up colliding. And that there's an elemental stuff in the universe that's clearly really doing that vector thing, okay, these little bits of photons. And, they're sort of the key to the whole thing in the sense that, they come in this huge range from the radio spectrum all the way to, theoretically, infinite frequency. But, some kind of very tiny thing moving a very tiny different distance, a Planck unit type argument. I wouldn't say that there is any such thing as a Planck unit of distance or time, but clearly it's divisible into motion, generally speaking. But anyway, so you have this stuff, this light, the speed of light stuff, and it really should be the speed of force. I think science should grow up a little bit and be able to say, we understand that all the forces, the discrete little bits that are moving very, very fast, they're all moving that same fast speed. And you can slow them down, like you can slow light down by shooting it through a giant pile of glass or something. But you're not technically slowing the elemental thing down. You're just creating an environment where it has to take a longer path because it's being deflected or diffracted in some way, altered in its usual function, but that the element itself survives. All right, so, I see the universe as that, right? There's those material objects, and I would argue the only elemental material objects are electrons and protons, and that you combine an electron to a proton, you have a neutron. And with those simple mechanisms of charge, you can build atoms, and you don't need anything else as an object except the interaction of those elemental matter bits with the force. I'm probably saying more than I want to, because I want to get to the particular subject, so I guess I'll go with the talking points that I wrote, because I want to, in some way, be able to convert these talking points into paragraphs that you, a listener, would be able to comprehend and understand why I can't see it your way. I mean, I can't even pretend to see it your way. It's like me pretending to imagine the Holy Ghost. I mean, well, yes, sort of. I don't know. What? He's got hairy arms. I don't know. I can't really do it. Can't play the game, and I can't play the relative bullshit. This idea that things move because there's some geodesic thing that tells them to, and you don't need a mechanical function, and it's not, forces aren't pushing us into the earth, and the earth's forces aren't pushing us back, and I just can't understand how you can see the universe as something other than a mechanical system with mechanical devices that are elemental and simple. And frankly, I've never seen it any other way. I just can't. I think even when I was a little kid, I didn't imagine a mechanical, some other mechanism. I knew that if I kicked my toy truck, the toy truck would roll and then it would stop. And, even then I knew, well, if I put bumpy crap in front of it, it doesn't go as far as that it has a smooth path. I mean, it's all sort of intuitive and obvious that interactions change things, and and there's all kinds of stuff interacting. I mean, I knew the sun hits the street gets really hot, I can throw my crayons on it and I can watch them melt. I mean, it wasn't difficult to figure out. I mean, I didn't need to think of it as being some mystical thing. Um, I could sort of feel the rays of the sun. I didn't think of them as some sort of entangled, superimposed wubicles. you know. So, so this is difficult because I'm saying, these people are really convinced that this wooey crap is real, and I'm just, how am I supposed to explain to them that no, the wooey crap is just wooey crap? But it should be as easy as somebody showing up with evolution and then explaining to a religious person, well, here's this much better theory. Instead of the fish story you've heard about the magical stuff that, you have no evidence for, here's a nice mechanical system. And people reject that out of hand, because they're afraid to do something else. Is that they're just afraid? Oh, I'll offend the God if I'm doubtful, so I'm not allowed to be doubtful. It's some kind of crap like that. Like they have to go to the default superstition and believe in it. It's like somebody gives them a voodoo curse. And, they think it's true. You step on a crack, it breaks your mother back. And they buy into it. They buy into some kind of, like life is a controllable wager or something with, mystical ideas, black cats and ladders and broken mirrors and, all this voodoo and woohoo. So, yeah, how do you explain? Because if that's all you people are, is voodooists, and you're just afraid, to recognize that, it's understandable. It's not mystical. It's not magical. It's mechanical. All right. So even more stuff. So yeah. It seems so simple, that's all I'm arguing. It just seems like such a simple mechanism, and why should I shouldn't even have to be here explaining it, because everybody should have already figured all this out. It's just so simple. All right, so I'll start with, there is no time dilation because time is a function, not a dimension. So that's the first thing you could just argue. Oh, come on, let's not talk baby talk. Let's not screw up language entirely. We know what dimensions are. They're by definition a thing, okay? And the thing they have to have, okay, is this right angle thing. The dimensions have to have right angles to each other. No other angle, just right angles. No other angle is allowed, just right angles. And there's no way to make a fourth dimension. Just can't do it. There's no way you can inject a new line and create right angles to the other three lines. So why are we playing with the word dimension, right? I mean, it's just cheating on its face to say that somehow time is something related to three-dimensional space when it isn't. Now, certainly you can cheat and pretend it is. Okay, you can sit there and take one of the dimensions out and put your time, call it a time dimension in, but it's not really a dimension, and it really doesn't have a place in time. There's no place in time. Okay, it's a continuum. The past is gone and the present doesn't exist yet. And those are just facts. All right. The future doesn't exist yet. Obviously, the present doesn't exist at all. There's just the gone past and the not existent future. And you're just in the crux between those two. All right, anyway. So let's not pretend that time is a dimension. Let's not talk like this is a dimensional thing. It's just not. And what is it? Okay. The mechanism of time is the speed of force. So this is something most physicists kind of grok, that the fastest thing that we can find in the universe would be a very good thing to set time to. Okay. And that especially if that fastest thing is insanely consistent, then you could say, okay, this is a pretty good mechanism for measuring time is just measuring how long it takes the fast thing to move a distance. And so that's a pretty good way of recognizing how interaction takes place in the universe, that it's all controlled by this fastest thing, and everything else is just complications of that fast thing happening. So, the real universe is going pretty fast. The electrons and protons are interacting, got trillions of interactions in every second of your existence. So the second, very fast. Well, it's very slow for an atom. Okay, I mean, a second is a very long time in terms of if you're going to count how many times the atom jumped up and down or something, or the electron wobbled. It's doing trillions of those things in our 1 second. And so the little tiny universe is the only universe. That's a whole nother subject, but I mean, it really is the only universe. It's the only place everything happens there first, and everything else, all of this stuff, that universe has to do it first. Electrons and protons know what you're going to do long before you do it, so to speak. They're already doing it, okay? Anyway. All right, so the mechanism of time is the speed of force, not the speed of light. It's the speed of all the forces. It's all the speed of the little bits of crap, okay, that we interact with all the time. They're going through us right now. Radio waves, cell phone calls, all kinds of shit is going into you and through you and bouncing off of you. So some of it bounces, some of it goes right through you, especially gravity. And you're interacting with it all the time, constantly. All the time. And the time is the interactions. Anyway, there is time because the speed of force is not instantaneous. So that's this simple argument that obviously if this most elemental moving bit, okay, was going without taking any time to go from one place to another, then there wouldn't be any time for there to be a universe and for things to happen. So you need some kind of elemental bit that's not going, okay, instantaneous speed. And as soon as you have something that doesn't happen instantaneously, you have the capacity for there to be this concept of time. But it's just a concept. There's no actual thing. There's just interactions in the universe at a rate decided by speed. There's just interactions in the universe at a rate decided by the speed of the stuff interacting. That's all. All right. The universe keeps time everywhere the same. So this one's okay. This jump. Oh wow! I forced you to make a big jump here. The universe keeps time everywhere the same. And the simple. It's a generality, okay, stating that if you look at the universe, and we have looked at it now pretty deep, okay, we've seen a lot of it, it's all the same stuff, a bunch of stuff, a little bit of clumpiness, all right, but mostly, generally speaking, it's just a huge amount of stuff in this, less stuff space. So there's a whole bunch of space separating the big clumps, and a lot of space, and the space is a lot less dense. There's a lot less bits of matter in this empty space that we call empty space, but it's not empty, right? So we know the space, okay, between, let's say, two electrons or something. We know there's this concept of space, but the space is full of this force stuff that we know moving around, right? So again, your cell phone calls, all this other stuff is going through that empty space. So the space isn't really empty because it's impossible, generally speaking, to go somewhere where that force can't get to you. But so the general statement is the microwave background radiation shows, or you could just look up into the sky and it sort of shows that there's a huge amount of consistency. There's not like twice as many stars over there as there is over there. It's the universe is functioning by perception basically the same, hundreds of millions of light years away, just the way it's interacting, here to there. All right. So it doesn't seem like that much of a reach for you to understand that the mechanism of time is the density of the force, but that's what we're going to get to. I guess that's why this one, the universe keeps time everywhere the same. I guess I have to put that later as a conclusion, because we haven't proven that yet, shown that. All right, generally speaking, the same amount of force permeates all sections of the universe. So yeah, that should go first. Okay. Maybe I could fix that now. Yeah, okay. Let's see. All right, so I'll take the universe does the same. Let's just cut that. And then also the force counts your interaction forces. Okay, so we could probably put it here maybe for now. All right. Generally speaking, the same amount of force permeates all sections of the universe. So that's probably the easier thing to grok, is that there's the same number of photons everywhere. There's not some place where there's a huge more stuff going through it and all that kind of stuff. There's just small locations where you can see a higher density of photons are coming out of that section, like where a galaxy is, it's a little brighter. Okay, but those, frankly, in spite of what it looks like, it's not all that. Okay, it isn't that much different. It's just what we can perceive. That's how what we're sensitive to. So we see a difference that is just a pretty subtle difference. It's just a difference in the frequencies, frankly. So we see some frequencies, we don't see other frequencies. So again, if you look at the universe in some other spectrum, things that are very bright become very dull, and things that are very dull become very bright, blah, 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 blah. All right. So this is the big one. Force counts your interaction with the universe. So the density of the force is constantly interacting with you, and every single one of those interactions is essentially a tick of time. So you could just, if we could possibly, right, this is just a thought experiment, well, it's not even an experiment, just the idea of understanding that, if I could make a detector that detected every bit of energy or force or photonic energy or stuff moving the speed of light, force, okay, and just count it as bits and just say, well, there's a trillion bits per 1/1000th of a second or whatever the thing would be that are passing through the space I occupy, and that's basically the timekeeper. And the simple argument I will be making is that no matter where I put that timekeeper, it's the same amount of crap. All right, I can change a little tiny amounts by, shooting a laser beam at you or some other kind of dopey stuff, but I'm changing a little tiny amount. The gross amount is, we're talking about trillions, and yeah, it can be 1,000,000,004, or 1,000,000,007, but it's the tiny difference, the real pressure, the stuff holding you together, the forces holding you together are incredibly hard to change. You can't only make tiny little changes, not big giant changes. And so generally speaking, the force is counting your interaction with the universe, the amount of force going through you, hitting you, bouncing off of you, all of that stuff is your interaction with the universe, and it just doesn't matter where I put you in the universe, you're going to have that amount of interaction. And like I said, all I can do is change it a little bit, okay, by putting you in gravitational fields and whatnot. But it's only a little bit. All right. Okay, the universe keeps time everywhere the same. So now we can say that statement that, once you understand it's the force bits that are keeping time, and that, it just doesn't matter where I put you. You're going to be keeping time the same because you're going to be absorbing the heat of the universe the same. So that's probably something that needs to be in here, is the force can be considered heat. And so you can say that the force in the universe, the amount of force you get hit with, I put you in space, the amount of force that's hitting you is essentially creating a temperature, because that's what matter does. It collects some of the force, and by collecting it, storing it, it gets hot because it's now moving matter bits. And so we can talk about the Kelvin scale, and it's just important to realize that there is in the universe, like there are 3 dimensions of real space, there's real temperature, and there's a 0. Okay, who knows how hot you can get, but you know how cold you can get. And 0 is this place where there's nothing moving. And the only way nothing can move is that nothing can be being hit by a force. And so that would be where there's no force hitting you. There's no pressure. There's no anything. And so that's impossible. And so everything in the universe, you could argue, every piece of space is really a pressure, and you could call it 50 Kelvin, for example. Now 50 Kelvin is minus 370 degrees Celsius, but it doesn't matter because we're made out of stuff that runs on liquidity. Okay, liquidity. We're in the liquid universe section, the part where things aren't rigidly solid and they are flexible and can move and can do all that stuff. So we're in a very hot universe. We need we need high temperatures to be able to function. But 50 Kelvin is still a high temperature, in that it's a lot of force. And so that's what's the default of being in space, is that you're going to be about 50 Kelvin. Maybe it's 35, it doesn't matter. But you're going to be at temperature because you can't get any lower than that just sitting in the force and being bombarded by it. All right, so force is made of discrete bits of stuff. So I guess this is where everything will go south, because you won't be able to imagine a photon as made out of elemental things moving a speed. But that's what it is. It's a mechanical thing. It's made out of a frequency is just the distance between bits of force. And you could argue polarization is just about the distance between the parallel lines of that force. So I can give you a model of a photon that's purely mechanical. Okay, it's not doing this stuff, it's not doing this, it's not being manipulated by any fields, it's not being controlled by any external thing, it's just discrete little ball bearings. And that's what I would argue that model can work perfectly to explain forces and their interaction with matter, that you can just make it out of little bits. See the little bits right down there? See them? See? That's what the universe is made out of. And if I put those things at a frequency, they'll cause a certain effect that's different than when they're not at a frequency. And if I put them at a high frequency, they'll cause effects that are different than if they're a wide frequency. And that's about tipping points and all kinds of other physical mechanics. But it's easily understood. That's all it is. It's mechanical. It's physical. It's as real as the bits of matter, the electron and proton. The force bits are just as real, just as mechanical. All right, generally speaking, the density of bits of force, I guess I should put there, is constant throughout the big universe. So that's just reasserting what I said earlier, that you can't escape it. And it's generally speaking of the same density throughout the universe. And the argument is that something happens around material objects that changes it a little bit, but it's only a little bit. Okay. All right. So yeah, I shouldn't have to reiterate that point. Generally speaking, the density of bits is consistent throughout the big universe. Okay, material objects can create a change in density. So this is a big one. I think I'll draw here, and because I've done tons of videos about gravity and how it works, but I'll just do a quick refresher. Okay. So when I have a material body, you have to understand the material body is just made out of electrons and protons. And the simple truth is that if you understood the force as just being free bits that can fly at the speed of light, and then you understand electrons and protons, that basically they can absorb that momentum arrow. So a force bit can interact with an electron and give it momentum. And when the electron moves, it's going to move a lot slower than the speed of light. So the speed of light force bit would have been here if it didn't hit the matter bit. But because it hit the matter bit, it's not going to be there. It's going to be here instead in the next moment of time. It's not going to be traveling distance at the same rate. But the matter bit will be, and that's the heat part that we can measure, is the motion of those little bits. So the simple truth is the force comes into something like the Earth, and the Earth is made out of a ton of electrons and protons, just an insane amount. And the simple truth is a bunch of it's going to stick to them. And so the force coming in over here is going to be slowed down substantially before it pops back out, because it's going to push a bunch of those electrons and protons. It's going to stick, then get reflected, then it's going to stick and get reflected and stick. So, it's going to be doing this as it interacts with all of this dense matter, this dense number of electrons and protons. And so this density of electrons and protons is gigantic, compared to the density of electrons and protons out here in space. There's barely any. Okay, so it's really low density, very high density. So obviously nothing's getting slowed down out here, and everything's getting slowed down here. So the simple truth is that the vector arrows at this moment going into the Earth are a little longer than the vector arrows coming out. The amount of force at this exact moment that goes into the Earth is greater than the amount going out at this exact moment, because clearly it can't get here. The force coming from below that should have pushed me, that should have created equal pressure on all sides, it didn't get here, okay, because it's busy heating the Earth and turning it into liquid metal. It's really busy down there, so it can't show up here to push me, to keep me from falling down. So obviously I have more force from the universe, the open universe above me. There's a whole bunch of force hitting me, and from below me, not so much. There's a differential. And so that's what we fall into, and on Earth it's 9.8 meters per second of velocity, okay? Increase in your velocity per 1 second. It's not seconds squared or any of that nonsense. So anyway, so the simple argument is you can kind of understand that the universe creates these differentials where theoretically, okay, you are in less pressure here. Now clearly the pressure coming from the top is the same. Pressure from the bottom is less. So you're essentially, if I had a counter counting how many bits of force are hitting me, less are going to hit me the closer I am to the surface of the Earth. Just a fact. This is the strongest gravity on Earth, is the surface. It gets weaker as you go in, gets weaker as you go out. So it gets weaker as gravitational pressure. Obviously it gets greater as material pressure as you go in, but the gravitational pressure gets less. But anyway, so the point is you can't go down, because the atomic pressure will compensate for the lack of gravitational pressure and crush you just as much, keep the same. It'll even make you hotter. But anyway, but going up, you're going to go into a place where there's more and more pressure, because the effect of the Earth blocking the pressure or slowing it down will become less and less strong as you go further away. The object gets smaller, okay, and its capacity to affect you gets weaker and weaker by the inverse square law. So you're in a place that is technically time dilated. If we just counted how many photons are hitting you, photons in the form of all speed of light force, okay, if we count them, the total is less here on the surface than it is, 10 miles up or 100 miles up. It gets weaker and weaker, and you get more of that force hitting you, and so your counter will go up as you go further and further away into the empty space. So near the Earth, time is dilated, okay, not really, but you're just being hit by less force. Total amount of energy hitting you is less. And obviously, if you were a clock made of something that was sensitive to how much pressure is coming from the external universe, you would say, I'm experiencing less universe. And that's what you're doing. You're experiencing less interaction with the universe. So you could call that time dilation. But it's not really dilating time. It's just saying you're having less of an interaction with the universe. There's a little less pressure on your material substance. You're having less interactions with the BBs. Yeah, that should be enough. All right, back to the story. Where we leave off? Okay. Material bits. A consistent material can create a change in density. So that's the simple argument. Where there's a clump of material objects, electrons and protons, they can reduce the speed of the force by causing it to push a bit of matter. And so the force isn't doing speed of light anymore, so in a sense it's slowed down, and now you'll have less interactions because the thing you were going to interact with has been slowed down and hasn't gotten to you yet. Alright, so that shouldn't be too hard to understand. Material objects effectively reduce force density in the space close to the material object. So that's basically just reinforcing the point that it's just around the material object. You'll have this force differential. It'll cause you to fall into the object, because you're in a differential. But the differential is an absolute less interaction with force, just because there is absolutely less of it hitting you from below. So you're not falling because something's pulling you. You're falling because there's an absence of stuff pushing you the way you would have been pushed if that material body wasn't there absorbing the push. And that's all there is. So that's the differential. But as a total amount of energy, it's very small differential. Okay. Let's see. Now the key, and this is another big one. Moving does not change the density of the elemental force you will interact with. So this part of time dilation, where they talk about velocity and moving, airplanes flying this way and airplanes flying that way and messing up clocks, they can't really mess up your total interaction. So you can't play a game that one twin flies out into space and pretend, that means that something really physical changed. So the simple argument is you can't really change how much force is going to hit you because the force is universal everywhere. So as you're moving, you're still going to be hit by the same amount of force, let's say, coming this way and this way. You can't escape it. So you can't change any of that. And all you're really saying is I'm going to hit more of it going this way, but you're going to hit less of it from this side. So, overall, you can't change it. So no matter how fast you travel through the space, you can't change your total amount of bits that are going to hit you. So again, if you're counting the bits, just like in Earth's gravity, except the answer is different when you're moving. So in Earth gravity, you have a real differential. But when you're moving through space, there's no real differential. You're just saying I'm hitting with more force from one side than from another side. But if I just count the total bits, the count will be the same. So moving isn't the same as being in gravity. Being in gravity is a real differential in how much force is hitting you. Moving isn't a real differential. But it is important to state that if it's important for the function of thing for it to be symmetrical, well, yeah, it might not be symmetrical anymore. Because if it's moving into more, it might be compressing and changing its shape relative to the fact that it is hitting more force forward than it's hitting in reverse. So again, if your timekeeper is a cesium clock or some other clock, and you're bending it, you could understand you're misshaping it. Well, maybe it's going to tell time different. So clearly it's an indication that yes, it is a different environment when you're moving. You've definitely changed how you're interacting with the force, but you can't change the total amount of force you're interacting with. So this is where it goes, it points right at the time dilation argument and says, okay, this is good reason not to believe. Because, you're pretending that I'm going to slow down and everything's going to go all funky and I'm not going to be... I can't change how much force is hitting me, though. The total universe is heating me up, is keeping me going. My electrons and protons don't think they're time dilated. Okay? They're, like I said, they might be busy trying to keep the atom from stretching and bending because of the fact that you're hitting more force in one direction than the other. But other than that, they're not going to play this I'm being time dilated game. And so if you thought of it as you being photographed by the universe, like the amount of force that hits you is just telling you how many photographs were taken of you, the universe is still photographing you the same. There's the same number of camera clicks. So you can't really pretend you're going to time dilate, because that would mean you're going to interact with twice as much force or 10 times as much force, and you're not going to interact in the normal way. You're going to interact in some new way, some changed way. You're going to reflect more, you're going to reflect less, you're going to, you can't change how much you're going to reflect. You can't change how much you're going to interact, how hot you are, essentially. You can't change it because the universe is insisting you're still in this universe where time is counted by the speed of this force, and so you haven't escaped the timekeeper. So you can't be escaping time. All right. So that part of the argument gets to this whole idea of what drag is and why things, you throw something in space and it keeps going, it doesn't get dragged to a halt, is because realistically you can't really change how much force you're going to interact with. You can only change when you're going to interact with it. It will show up, like in Earth's gravity. If I could jump just a moment ahead in time, all the force that I was waiting on would be showing up. So it's still going to hit me technically. It's just going to hit me too late. It's going to hit me after I already fell. I already fell in the deficit, and it can't undo the fact that I already fell in the deficit. And so, you're always stuck with that fact that a moment later it'll show up and fix the problem, but it won't be until a moment too late. But the real amount you can't change. Let me just think of some other way of saying that. So say if you understood that you're dragging to a halt because you're hitting more stuff going this way, you can understand that as soon as you slow down, all the stuff coming from this way is going to hit you now. So it's going to rebalance your velocity and give you back the velocity you lost. There's no way you can say, okay, I jumped ahead of a bunch of stuff and it's never going to catch up. Well, that doesn't make any sense. It's never going to catch up. Bullshit. It'll show up, and in the form of it has to. You can't undo it. So as soon as you start slowing down, you start getting hit by more force from behind. You're going to be sped up again, so you're just going to kind of jerk your way through. But you can't change the total amount of energy that's shining this way and the total amount shining this way. All right, anyway. So it's a complex concept in the sense that, there's lots of arguments you have to make about how the density can't be changed, even though, you did over a period of time get hit more this way than that way, that you can't really change the fact that it will rebalance. Okay, so moving does not change the density of elemental force you will interact with. So I'll say that's going to be one of the most challenging arguments to make in detail or depth, but it's a fact. And that's why things do keep going in space, is because even though they're hitting more stuff in the direction they're moving, it's only a temporary condition. They can't really hit more stuff in the forward direction. Interacting with matter is equivalent to interacting with a higher density of force. So when you hit matter, that's like hitting, so hitting the force, that won't do anything. Going into a force and hitting more force, that won't have any effect, but hitting matter will. So if you hit clumps of matter, it is going to be like you're hitting a higher density of force. So again, it changes the density argument again. And so you will interact with more force, and just as if you were in a gravitational well. So in some sense, when you're moving really fast through space, the problem's not going to be interacting with the force. It's going to be interacting with the little clumps of matter. They're the thing that are going to start degrading your velocity and doing all kinds of other stuff that you're going to have to compensate for. And the compensation will be essentially to restore you to the original amount of bits you're getting hit per unit of time. But anyway, so there are ways to create subtle difference in how much energy is hitting you per trillionth of a second, but the differences are going to be tiny and insignificant to your total condition. All right, you can't, so this one isn't really, this is just a throwaway statement. You can't dilate time. You can only find locations where you interact with slightly less force. And interacting with less force or non-symmetrical force, you could argue, breaks clocks. But you never dilate time. You never get out of the universe. You never get away from the time-keeping photonic energy that exists everywhere in the universe at essentially the same density. You can't escape the real timekeeper. Okay. So that's a start anyway. This is, like I said, this is more because of a personal frustration I have with writing. It's just, I find it very difficult in my old age. Partly because, yes, you have to search for vocabulary and how to say things. But I think it's more just about out of the personal experience of how frustrating it is to explain even the simplest things to other people, and how difficult it seems to be to explain just a very simple concept. It sort of goes to subjects like, years and years ago I proposed that it would be so much better for our civilization if we paid kids to learn instead of paying teachers. And I proposed this back before the internet, but we'd already had libraries, we already had institutional mechanisms through which you could gain a huge amount of knowledge. But certainly with the introduction of the internet, I really started pushing it because it's just so obvious that you can just videotape the best teachers in the world and have the kids watch that. All of this performance art is useless nonsense, wasted energy. And if we took those resources, if we took that $150,000 that you pay for the average high school graduate and put it there in front of a kid and said, look, you're going to get paid $150,000 to pass this GED, to pass a rigorous test on all these subjects. You could have high school graduates at 11 years old, and probably even younger. Might have taken me, 11 years old. I mean, I was making, 3 cents per paper, deliver papers as a kid. I mean, it'd be, why would I beat my body to pieces, freeze to death, jeopardize my future health, when all I have to do is open a book and learn, and I'm going to get paid this ginormous amount of money. And I'm just saying it would be so much more effective to pay the kid, because the kid has to do the real work. He has to not go play football or not do this and not do that and not do what he wants to do. And he has to do this annoying thing of learning how to, switch and multiply and do all this other transactional, learn what the geometry is and whether the angle, side angle and Pythagorean stuff and all. Yeah. But if you have a gigantic reward sitting there in front of them, that huge giant incentive, It's like it's like offering them a bigger penis. I mean, $150,000 is a bigger penis. You know, and the fact that you can't even get people to understand that, you know, just how obvious it is, how great it would be for civilization if we did that. You know, yes, some teachers getting unemployed. So what? I mean, who cares? You know, it's such a minor. Get a real job. No big deal. Okay, okay. They're not going to get great jobs. I remember my earth science teacher when I was in high school. You know, so that was like the first freshman year science. He used to deliver mail on the weekends. You know, so yeah, okay. Teachers aren't qualified to do anything. So they're going to have a degrade in their standard of living. But tough shit, frankly. I mean, it's a tough world. You know, I couldn't do any better. I mean, I cut grass. I did all kinds of shitty jobs to make a living. Well, and I did not even make a living. So anyway, I'm not saying, you know, we shouldn't. There's lots of economy to fix. But this is just the wrong incentive placed in front of the wrong machine. It's just it's putting the grease you know, on the bumper. It's, you know, instead of the wheel. It's just so damn stupid and wasteful. But anyway, so the point I'm making is there are things you could argue are so brilliantly simple and obvious and true and sensible, and you can't get people to, you know, they just, what, you're saying we should change something? I mean, everything sucks. Yeah. But change is, that could be suckier. Could be. Or, I mean, nothing. And you're saying, okay, so you can't even explain something perfectly brilliant to people. And now I'm going to try to explain something a little bit more complicated. And I don't even see it as complicated, because I'm saying I don't even understand how you could physically understand the universe any other way than 3 dimensions of space with crap flying through it. How the fuck are you thinking of it as any other kind of machine? I can't even imagine what's in your fucking brains. And so I'm supposed to write a script explaining how you transition from what I see as my clear vision to your completely noisy, nonsensical, wooey, shitty voodoo bullshit. And how do I make that? How do I create that Rosetta Stone? So that's why writing is frustrating, because you're just saying, how are you not understanding the sentence? How does it fail to impress you? Yeah. But anyway, it's been my whole life. This is still the world. This is the earth I live on. It's full of intractable moronery. And so there's nothing I can do. Intractable moronery. See, I'm still capable of a little bit of brilliance. Intractable moronery. It's great. It's a perfect title for a book. Intractable moronery. Okay. Yeah. Well, anyway, so like I said, the video is mostly for me. I'm hoping that I can turn this into some kind of written statement that I could attempt to get published as a simple, oh, come on, you people really don't think this has to be all this wooey shit, right? There is simple answers that work. All right. Anyway. So, till the next time and such and so forth and whatnot, when I continue to suffer trying to communicate with human moronery.